Welcome to the lesson on variables in algebra. In this lesson, we will introduce some of the basic principles behind algebra, one of the more complex but fundamental branches of mathematics. By definition, a variable is a symbol, usually an English letter, that takes the place of a number. Extending from this, algebra is a branch of math dealing with unknown values and how we find them, that is, those values, to solve real-world problems. So we started taking a look at one of the basics. 3 plus what plus a blank plus a space equals 5. Now this space is usually where our variable goes. So we think what added to 3 will give me 5. When visualizing it, I think 3 plus x, the quantity that we do not know, equals 5. 3 plus x equals 5. I imagine this being on a scale where 3 plus x, that quantity is equal to 5. So whatever x must be, when added to 3, it should give me 5. So thinking about the process, if we just take away 3, we're going to have an unbalance, and 5 is going to end up being more than x if I just take away the 3 from x. If instead we think to take away the 3 from both sides, and I take away the 3 from the x and the 5, I'll have x and 2 on either side of the scale, and we'll have balance achieved. But why is this? Why do I take away 3 from both sides? And why in particular did I get a 2 on the right side? So let's take a look at another example and perhaps it'll make more sense. N plus 8 equals 22. Again, some quantity added to 8 equals 22. In order to figure this out, let's take away 8 from both sides by subtracting 8 from both sides. Well, on the left, 8 minus 8 is 0, and on the right, 22 minus 8 is going to equal 14. Ultimately, I bring the n down and n plus 0 equals 14. I don't need to include the 0, so n equals 14. Thus, the quantity that I did not know at the beginning, that n, ended up being 14. But what allowed me and what keyed me in to know that I would subtract 8? Well, the process involved using inverse operations. That means I'm going to use the opposite of whatever operation is present and around my variable. Let's take a look at more examples. A minus 3 equals 10. To get rid of a minus 3, I'm going to add 3 to the 3, and of course I have to add 3 to the other side to maintain balance. Well, minus 3 plus 3 will give me 0, and a positive 10 plus 3 will give me 13. I'll drop the a down. A plus 0 will end up being equal to 13, so a equals 13 since I do not need to consider the 0. Let's look at 6x equals 18. 6x is the same as saying 6 times x. So I can divide both by 6 as the inverse operation. 6x by 6 and 18 by 6. 6 by 6 will give me 1, so I'm left with 1x, and 18 divided by 6 will give me 3. I don't need to consider the 1, so at x equals 3. Once I have that variable by itself, I've solved for it. In the last example, I have x over 4 divided by 20. And x over 4 is the same as saying x divided by 4. So I'll do the opposite and multiply this side by 4 and the other side, the 20, by 4 as well. 4x divided by 4 will give me 1x, and on the other side, 20 times 4 will give me 80. Since I do not need to completely consider the 1, I again am left with x by itself equals 80. So that was my unknown quantity, 80. Looking at the connection between algebra and the real world is very strong, as in many cases we will use algebra and its basic algebra problems to help us find the unknown quantities in our world that we do not know.